In this simulation video, we'll be taking a look at the beam splicing options for the Evolution steel beam. Before we get started, here's a list of the recommended tools and safety equipment you'll want to have on hand when working with our Evolution steel framing product. Know that all posts must be temporarily braced until fully stabilized and permanently connected with framing or other structural members. For deck frames, this means that all beams, joists, hangers, and any blocking that shores up the structure should be in place before the bracing can be removed. In short, the deck frame should be fully assembled and secured first before bracing is removed from the assembly. There are typically going to be two options used when splicing an Evolution beam. One method is end-to-end or butt splicing the beam over a post. Know that currently butt splicing can only be performed with the Evolution 5.5-inch post-to-beam bracket. This can be done in either single or double beam configuration. The other method is lap splicing, which is short for overlap splicing, where two beams will slightly overlap and be joined together. This splicing method is the only means to currently perform splicing with an Evolution 3.5-inch hardware set to make longer stretches of deck. The lap splice can also be performed with the 5.5-inch hardware setup as well. Let's first look at end-to-end beam splicing over a post. To perform the end-to-end splicing method, simply install the brackets to the posts. Then set your first cut-to-length beam in place, allowing it to split the post and rest on the post cap piece. Once the first beam is in place, use Evolution self-tapping screws to lock it in position. Then slide the next beam in place, allowing it to butt up against the first beam. Secure it in place with more Evolution self-tapping screws by filling the pre-punched holes in all the post-to-beam brackets. This is a simple splicing method that uses the existing bracket hardware to complete the splicing method. For more detailed instructions on the installation process of the 5.5-inch post-to-beam bracket, please see our video for either the single or double beam configuration. Up next, let's look at the lap splicing method. In our demonstration here, we'll be performing this splicing setup on a 32-foot wide deck with two beam splices. It's important to consider the overall length of all the beams once spliced. This measurement needs to match that same 32-foot length of the ledger board. So we need to take those overlap sections into consideration when measuring and cutting any beam lengths for the overlap. For the lap splice, it's a requirement that the spliced section has the beams overlap by a minimum of 24 inches in each direction. Another standard requirement is that there has to be a post under the overlap section or splice. The post can fall anywhere under the splice, but it cannot be outside the overlapping section. This can often lead to needing to purchase longer beams and then cutting a beam to length. If cutting is required, be sure to follow the standard process for cutting the product outlined in the Cutting Evolution product video or instruction manual. One final point to be aware of is about the post-to-beam brackets. Here on each end where there are single beams, the post will be equipped with single beam brackets, while the middle two posts that are supporting the splices or two beams will have double beam brackets. The splicing process will begin once the beams have been prepped and mounted to the brackets. The lap splice will be formed by bolting the overlapping beams together. So holes will need to be drilled through the beams in the splice section. This will require a minimum of 4 bolt holes for the connection process. So first, drill the connecting bolt holes for all 4 connection points. The holes will need to be able to accommodate a 3/8-inch diameter bolt. It's best to use a longer bit and drill all the way through both beams. When drilling, try to keep the drill level and drill through both beams at the same time, from one side all the way through the other. This will ensure the bolts will align when inserted and create pilot holes for the next drilling step. Once all 4 holes have been drilled, swap out the 3/8 drill bit for a metal cutting step bit. Take this bit and center it on the 3/8 hole here on the outside of the beam. Then use the step bit to drill out a hole large enough to accommodate a washer and a socket to hold the bolt. This hole will generally be around 1 inch or 24 millimeters in diameter, but can be a little larger than that. Note that this process will need to be repeated on the back side of the splice as well. Once the faces of all the beams have been drilled, take a drill with a 9/16 socket and insert the bolt and washer on the front side. Then set the nut in a socket and insert it through the back hole and tighten the connection. Note that the bolt shown is 3/8 inches in diameter by 1.25 inches in length. Know that this diameter is the minimum requirement and that a larger bolt can be used. Repeat this process for the other 3 bolts to finish connecting the lap splice. Then repeat this process for any other splices in the build. On a final note, for deck finishing purposes, you can additionally add another beam section in front of the middle inset section to make the beam run have a flush appearance. To do this, utilize the same bolting method that was just shown. Alternatively, since this beam is purely for aesthetic purposes, it can be attached to the middle beam prior to the splicing process. That can be accomplished by tacking it on the inside of each end of the beam with Evolution self-tapping screws. For more information on our steel deck framing products, including where to buy, stop by our website at fortressbp.com/framing. And don't forget to check out our other Evolution steel framing videos as we continue to help our customers steal the show.